Welcome to Daily Conversation. This is Mr. K.
This is Eric.
Yeah, today is the 2nd of October 2021 and the time now is 6:16 a.m. Well, today is a reading session and we are going to continue reading the book Eat to Beat Disease. Right, so before we get started, please click the like button and subscribe to our YouTube channel. All right, so here we go.
Part 1. Hardwired for health. Our body's natural defense system. Natural forces within us are the true healers of disease. Hippocrates. Health is not simply the absence of disease. Health is an active state. Your body has within it 5 health defense systems: angiogenesis, regeneration, the microbiome, DNA protection, and immunity. These systems are responsible for maintaining our health and resisting the regular hurdles we all face every day as part of ordinary life, and they heal us when incursions from disease inflict damage in our body. By knowing about how these systems defend your body like a fortress, you can tap into their healing powers to live a longer, healthier life.
Each of your health defense systems has a fascinating story of research and discovery. Each is supported by a well orchestrated symphony of players, organs, cells, proteins, and more. Each is a common denominator for preventing not one but many diseases. And all 5 systems work together to keep you in great health from the time you are in your mother's womb until your last breath. Join me in the next 5 chapters to get to know these systems and the benefits they can offer.
Chapter 1. Angiogenesis. We all have cancer growing in our body. Every single one of us, even you. In autopsy, in autopsy studies on individuals who never received a diagnosis of cancer during their lifetimes, almost 40% of women between the ages of 40 and 50 had microscopic tumors in their breast. About 50% of men between 50 and 60 had microscopic cancer in their prostate, and almost 100% of people over the age of 70 had microscopic cancer in their thyroid glands. One, one tumors such as these develop when healthy cells make nature's errors during cell divisions or when cell's DNA is mutated by environmental exposures. Up to 10,000 mistakes occurred in the DNA of dividing cells in your body every day, making the, the formation of cancers not only common but inevitable. And yet, these microscopic cancers are completely harmless. Most of them never become dangerous. They start out tiny, smaller than the tip of a ballpoint pen, and as long as they cannot enlarge and invade organs, they cannot spread and kill.
Your body has a remarkable defense system that keeps microscopic cancers small by starving them of the blood supply and nutrients they would need to grow. Nutrients. And you can optimize this defense system through the foods you eat. More than 100 foods can enhance your body's ability to starve cancer and keep those tumors small and harmless. Among them, soil, tomatoes, black raspberries, pomegranate, and even some surprising ones like licorice, beer, and cheese. Your defense weapons to keep these tumors at bay can be found at grocery store, the farmer's market, and in your garden.
The last three line, last
Yeah.
second vocab is licorice.
Li- licorice. Okay.
Uh,
Licorice.
the, the, the last phonetic is sh, and
Oh,
just now you pronounce like uh licorice is something like that.
so is licorice. Licorice. Is it correct?
Yeah, yeah.
Okay.
The defense system that allows our bodies to intercept cancers this way is called angiogenesis. Angiogenesis is a process of our bodies used to grow and maintain blood vessels. In ordinary circumstances, blood vessels are supporters of life, delivering oxygen and vital nutrients to all of our organs. But when abnormal blood vessels grow, they can nourish microscopic cancers. A healthy angiogenesis system regulates when and where blood vessels should grow and can prevent tumors from, from recruiting a private blood supply for the oxygens they need to expand. When the body loses this ability to control blood vessels, a wide range of diseases can occur, including cancers.
As long as the angiogenesis system operates properly, blood vessels grow in the right place at the right time. Not too many, not too few, but just the right amount. Keeping this perfect balance in the circulatory system is at the heart of how angiogenesis defends health by keeping us in a state called homeostasis. Homeostasis. Homeostasis is defined as maintaining stability in the body for normal function while adjusting to constantly changing conditions. Angiogenesis plays a vital role by creating and maintaining your entire circulatory system and adapting it to various situations over the course of our life to protect our health.
Because of this powerful health defense system that naturally cuts off the blood supplies to tumors, cancer doesn't have to be a disease. In part 2, I will share how the latest science of angiogenesis is shaping our understanding of which foods can help your angiogenesis system maintain homeostasis, homeostasis and how you can eat to starve cancer, grow vessels to feed your heart, and, and stave off deadly diseases to live a longer, healthier life. But in order to fully appreciate how food influences angiogenesis and your health, let's first take a look at how blood vessels go to work for you every day.
Angiogenesis at work. Inside you, there are 60,000 miles of blood vessels whose job it is to deliver oxygen and nutrients to keep cells alive. These are the vessels of life that nourish our healthy organs and protect us against disease. If all your blood vessels were lined up end to end, they would encircle the earth twice. Remarkably, it takes only 60 seconds from the time your heart pumps out a drop of blood for it to circulate throughout the body and back again.
The smallest blood vessels are called capillaries. They are finer than a hair, and your body has 19 millions of them. Capillaries have a unique relationship with all other cells because they are the final link in the chains of the blood vessel delivery system to your cells, because they are at the end of the line. Virtually every cell in the body is located within 200 micrometers from a capillary. There's really close proximity, just at just a little more than the width of a human hair. Each organ has its own unique density and patterns of capillaries, depending on what the organ does and how much blood flows it needs. Your muscles, for example, have a huge oxygen demand, so they need 4 times more blood supply than your bones, which act as structural support. Other high-demand organs for blood flow are your brain, heart, kidneys, and liver. All of these have a capillary density of an amazing 3,000 vessels per cubic millimeter, which is 30 times that of that of bones.
Under the microscope, capillaries look like works of art, sculpted, sculpted to fit the organ in which they are growing. The ones feeding your skin look like rows of Velcro hooks with loops after loop of vessels providing the blood that gives warmth and color to your body's surface. Along your nerves, from spinal from spinal cord to fingertips, capillaries course along like telephone lines feeding neurons and keep your senses sharp. In the colon, capillaries are formed in a beautiful geometric honeycomb pattern, so they can stretch with the colon as it fills with digested matter, while providing maximum surface area to absorb fluid back into your bloodstream.
The importance of angiogenesis to support life is so fundamental that it begins in the reproductive system even before conception. By the time a sperm but by the time a sperm meets an egg, the womb has already been prepared with the endometrium, a lining of new blood vessels ready to receive and nurture nurture the fertilized egg. If no pregnancy if no pregnancies occurs, this lining is sloughed off every month during menstruations. If the fertilized egg is implanted, the blood vessel acts as the first supply lines for the developing fetus. About 8 days after implantation, a new vascular organ, the, the placenta, is created to bring blood from the mother to the fetus. Over the next 9 months, a symphony, a, sym a symphony of angiogenesis takes place within the fetus, forming an entire circulatory system from scratch, and then filling up each organ in the developing body. Toward the end of pregnancy, as the body prepares for birth, the, 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 the placenta releases a natural anti-angiogenic factors called soluble FIT1, which slows down the building of blood vessels. This ability to turn on, turn down, and turn off is a hallmark of the angiogenesis health defense system, not only for building life during pregnancies, but for protecting our health for life's duration.
Angiogenesis defense is a method to protect all animals with a circulatory system, including humans. Whenever you suffer a deep cut, whether from surgery or trauma, you've no doubt noticed the wounded area starts to undergo changes within seconds, launching a process that continues until the wound is healed. If you've ever scraped your knee badly enough to bleed and later form a scab, and if that scab pulled off too early, you have seen this process unfolding before your eyes. Underneath the scab, the tissue was bright red and glistening. In that red patch, thousands of new blood vessels were growing in the wound to restore the injured tissue back to health.
When you see this process, you are, you are, you are witnessing angiogenesis, which is jump started in wounded tissue as soon as bleeding begins. The trigger is hypoxia, or lower oxygen level caused by the interruptions of normal blood flows in the injury. Lack of oxygen is a signal for more blood vessels to grow to bring in more oxygen. Hypoxia causes wounded cells to start releasing proteins, signals called growth factors, whose job is to stimulate angiogenesis. Inflammation is very important at the beginning of healing. Inflammatory cells called macrophages and neutrophils crawl into a wound to clean up any bacteria and debris from the injury, and they themselves release their own angiogenic growth factors amplifying the blood vessel generating response.
Yeah, the third line from the bottom, which is this one, I think is debris and without the pronunciation of S behind.
Oh, okay. The breeze.
From here, several events unfold on the cellular level to grow blood vessels. Thanks to, thanks to special cells lining your veins called endothelia cells, a rescue team is waiting to receive the growth factor signals that instruct the endothelia cells to deploy. Roughly a trillion of roughly a trillion endothelia cells line your circulatory system, making them one of the most abundant cell types in your body. Think of each of these endothelia cells as a car engine connected to an ignition switch. Now imagine the growth factors that were released from the site of the injury as car keys. The growth factors fit into specific receptors studying the surface of endothelia cells, just as car keys fit into ignition switches. When the right key goes in the right switch, the engine turns on, and the endothelia cells are ready to start migrating toward the source of the protein growth factors and start dividing and forming tubes that will turn into new blood vessels. But first, the endothelia cells need to get out of the vein. They release enzymes that digest the sleeve-like wall of the vein outside the cell, creating holes in the vein wall. From this point on, the deactivated endothelia cells begin sprouting out of these holes, following the gradient of growth factors being sent from the injured area, and building new blood vessels in that direction. As blood vessels sprout elongate, they roll up lengthwise to create tubes. Tubes eventually connect at their tips to form capillary loops. As more and more capillary loops form in the healing zone, a new circulation for healing is born.
Freshly formed, freshly formed blood vessels are way too fragile to support blood flow on their own, so they are assisted by another type of cell, the, the pericyte, which helps them mature. Pericytes help out in a couple of ways. First, they wrap themselves around the endothelial tubes like a tube sock over an ankle to provide architectural stability. Simultaneously, the, the, peris, the pericytes slow down angiogenesis so that so there isn't a super overreach of blood vessels. The pericyte cells are shifter, shifters. Once anchored, one anchored to a new blood vessel that extend tentacle-like tentacle-like arms to embrace the endothelial cells around them. A single parasite can touch as many as 20 cells at a time and release a chemical signal that turns off the, the, fren- the frenzies activity surrounding angiogenesis.
Once the new vessels have sprouted and been stabilized, blood flow begins. The flood of new oxygens turns down the switch for growth factors signals, slowing the engines of angiogenesis until they finally grind to a halt. At the same time, natural angiogenesis inhibitors are released in the area, further suppressing new blood vessels growth. When the new blood vessels are solidly in place, the endothelial cells lining them churn out proteins called survival factors that help heal cells in the neighborhood where angiogenesis took place. When properly constructed, these defensive new blood vessels can last for a lifetime, keeping the skin and other organs alive.
The angiogenesis system constantly senses where and when more vessels are needed to keep organs healthy and functioning. The master builder blood vessel detects the need from your muscle after a workout. More blood flow is needed to build muscle. On the other hand, the system is also constantly on the lookout for situations where blood vessels should be pruned back, not too few or too many, but just the right balance and mix of blood vessels is what a healthy angiogenesis system is designed to accomplish 24 hours a day.
It's like a dimmer switch. The intensity can be up to grow more blood vessels when there's a need. When it needs to be dimmed, your body has an endogenous naturally occurring in the body inhibitors of angiogenesis that squelch the process. These stimulators and countermeasures are everywhere, including our muscles, blood, heart, brain, breast milk, and even semen.
Your body's control of angiogenesis needs to be perfect to optimize your health over the course of a lifetime. However, many factors can derate this defense system, leading to either excessive angiogenesis, which can feed disease issues, or, on the other hand, insufficient angiogenesis, which can lead to tissue loss and, and death. You are going to learn about the foods that help shore up your angiogenesis defenses to help your body resist diseases in part 2. But first, let's return to the microscopic cancers growing in your body to see how breakdown of the defenses happens and its dire consequences. So you can learn why it's so important to eat the right foods for health. The main reasons microscopic cancers don't grow is your body nature angiogenesis inhibitors. These countermeasures keep tumors in check by depriving them of a blood supply, as researchers at Harvard Medical School discovered as early as 1974. So long as no blood vessels grow to feed tumors, the cancer cells will remain dormant, dormant will remain dormant and harmless. Your immune, your immune system, which I'll tell you about later in chapter 5, eventually spots them and destroys them. Over time, however, some tiny nest of cancer can overwhelm the defense system and overcome an anti-angiogenic countermeasures by releasing huge amounts of the same growth factor signal involved in wound healing. In lab experiments, once new blood vessels sprout into a small cluster of cancer cells, the tumors can grow exponentially, expanding up to 16,000 times its size in only 2 weeks after angiogenesis starts. When tumors hijack the angiogenesis defense system to grow their own circulations, a harmless cancer quickly becomes a potentially deadly one. Worse yet, the same blood vessels that feeds cancer tumors also serve as a disease channel to malignant cells to escape into the bloodstream. This is known as meta- metastasis, metastasis, and is the most dangerous aspect of cancers. Patients with cancers rarely die from their initial tumors, which can often be removed by surgeries. Is the metastasis that pep- that peppers the body like buckshot that kill.
Helping the body prevent unwanted angiogenesis can have the powerful effect of suppressing cancer. The goal is to boost your angiogenesis defenses, helping your body's natural countermeasures keep blood vessels in the normal zone of balance, which means cancer cells do not have the advantage of being fed so they can't grow. The first patient to benefit from an anti-angiogenic treatment was a 12-year-old boy named Tom Briggs, who lived in Denver, Colorado. He was diagnosed with a condition called pulmonary capillary hemangiomatous, in which tumors grew in his lungs. As the tumors expanded, his breathing became difficult and it interfered with his ability to play his favorite sports like baseball and sometimes even to get a good night's sleep. As a last-ditch measure, he received a medicine called interferon alpha, which his doctors knew could stop angiogenesis. Over the course of a year, his lung tumors shrank away, and Tom returned to living life as a normal kid. Tom's case was so remarkable that it was published as a first human case in the New England Journal of Medicine as a glimpse into the future of treating tumors.
Biotech companies began developing targeted drugs to treat tumors angiogenesis starting in the 1990s. The first cancer to show the benefit of anti-angiogenic therapies was colorectal cancer, where targeting tumors blood vessels improved patient survival using a treatment called Avastin. Many other cancers have become treatable by boosting the body's own angiogenesis countermeasures. Using Avastin and more than a dozen other designer medicines that inhibit angiogenesis. These include kidney, lung, brain, thyroid, thyroid, liver, cervical, ovarian, and breast cancer, as well as multiple myeloma. In 2004, the U.S. Food and Drug Commissioner Mark McSillan declared angiogenesis inhibitors can now be considered as the fourth modalities of cancer therapy after surgery, chemotherapies, and radiation.
Excessive angiogenesis drives disease in many other conditions beyond cancer, such as vision loss. In the healthy eye, vision is possible because light can pass through crystal clear fluid to the retina and be re registered by the brain without interference from blood vessels. Angiogenesis in the eye is so tightly controlled that the endothelial cells lining the blood vessels in the retina normally divide only twice in a person's lifetime. But in both age-related macular degeneration, the leading cause of blindness worldwide in people aged 65 and older, and diabetes-related vision loss, angiogenesis leads to abnormal tangles of blood vessels being formed, which leak fluid and bleed. This disastrous consequence of unwanted angiogenesis destroys vision. Fortunately, these conditions can now be treated using FDA-approved biological medicines that are injected by ophthalmologists into the eye to halt the destructive angiogenesis, stop the leaking, and protect vision. Some patients can even regain lost vision. I had one patient who became legally blind from macular degeneration and could not drive or play golf, her favorite pastime. After treatment, she could safely drive again and got back to working on her backswing on the golf course. Yeah.
Yeah. So, do you want to make a summary?
Yeah, okay. All right, so yeah, with my little knowledge in this field, and I think I try to make a summary based on what I know, and yeah, firstly, it talked about health is it's actually a state. Yeah. So like we said, if we don't have disease, it doesn't mean that we are healthy. And then when talk about health in this book, it basically relate to five of our defense system, our body defense system. Uh, yeah, again, I mention it again, which is angiogenesis, regeneration, microbiome, DNA, and then immunity.
DNA
Yeah, and
protection.
oh, DNA protection. All right, DNA protection, and then immunity. So for chapter one, it talks about the first one, which is angiogenesis, and then also talk about angiogenesis can be good and can be bad if it didn't function well. And for example, cancer. For cancer, they basically treat cancer by uh, make the angiogenesis not to build the blood vessels. So we have something like angiogenesis inhibitors. This is something that stop the blood vessels level, bring down the blood vessels level or the growth levels. Yeah, and then um, yeah, in this way, it is kind of to starve the cancer cell by not providing them the blood. So the cancer cell couldn't grow also. And also to mention that in every person's body we have the cancer cells. Yeah, but normally because of our angiogenesis system, they are remain dormant and harmless. Yep, and then um, yeah, and there's a part talk about the cut and wounds. And whenever we had cut and wounds, yeah, I forgot the um, I forgot something, but there is something that give signals for the uh, for more cells vessels to grow, and then so that the wounds will be healed over time. And then for cancer, they also kind of using the similar techniques, and they hijack our defense system, and they call they release the signal for more cell vessels to grow in that part. But the purpose of this is to feed the cancer cells. So this is something not good, and we didn't want to see. And then yeah, so in conclusion, the excessive of the excesses of the the angiogenesis level, it feed disease tissues. And then on the opposite, if we have insufficient uh, angiogenesis level, and then we may suffer from tissue loss. Yep, and then in the last part also talk about our vision, and then also has got something to do with angiogenesis. Yeah, so these are my sharing summary.
Yeah. Uh, for my summary, yeah, because this is too technical and medical, and so, but to try to understand, uh, this part is talk about the angiogenesis. I will, I will say like this: angiogenesis is to form the blood vessel, and blood vessel is very important through our bodies, including our brain.
Yeah,
We need the blood vessel, and our heart is very strong. And The length of our blood vessel can like surrounding the earth twice, and our heart just needs 60 every 60 seconds to pump the blood to the whole body. Yeah, and yeah, angiogenesis is to form the blood vessel. So when you get injury and the injury part of your body lose the blood vessel because it get injured. So in the angiogenesis play the role to recreate, to form the blood vessel. Yeah. And like I said just now, a blood vessel is crucial to keep the cells alive. So it also means to keep our body alive. And some parts of the of our body use more blood vessel as well as angiogenesis than other. For example, brain, muscle, and heart. Yeah. So this is the part which we know we also need a lot of blood. So it also needs it also will have a lot of blood vessel and angiogenesis. If you want the tumor die, what you need to do is stop providing the blood, providing the food to them. Yeah. And the blood will actually deliver the nutrients and the foods to the cell. So it's something like you want to starve. You want to starve the cancer cell. You want to starve the tumors. So you should stop providing the blood, and also it also means that you want to like stop providing the angiogenesis to the tumors. And it's not only yeah. So as here we can know that if you produce more angiogenesis, you will feed the tumors, which is called the excessive angiogenesis. And if you have too little angiogenesis, your blood vessel cannot be formed after you get injured. After you get injured, and then it may also lead to some disease because of infections, and also some other bacteria will hurt your tissues. Yeah. So what we need to do is keep a balance. And how to keep a balance? We haven't like get the answer from these reading sessions. Yeah. So that's my summary.
Yeah. Summary. Your summary is good and clear. Yeah.
Yeah. Okay. So anything want to add in?
Yeah. No.
Okay. So that's all for our today conversation. How do you feel? Did you enjoy the conversations? Please tell us what you think of our conversation. And we are not native speakers. If you found any vocabulary mistakes that we made, please also comment to let us know, because we want to learn more and improve ourselves. Remember to like, subscribe to us. Thanks for watching. See you tomorrow.
See you tomorrow.